All right, so we're going to try to do a quick tutorial of another way we can divide polynomials. Obviously, long division takes a long time. But when we have a particular case like this, when our divisor is a linear binomial with a coefficient of 1. In other words, it looks like x plus or minus some number. Okay, it can be any number. So x plus 5, x minus 2, etc. X plus or minus any number. We can use a faster method called synthetic division. So let's take a look at an example. So let's say I wanted to divide this cubic polynomial by x minus 3. Well, this certainly fits our form, so we can use synthetic. Now, we, of course, can do this with long division, but we're looking at a faster way here. So the first thing we do is we need to take our divisor, x minus 3, and find its 0. So set it equal to 0, and we would get positive 3. Think like when we use zero product property, and we set factors equal to 0. That's basically what we do here, but we put that in the corner. Okay, so we're going to put this in this little kind of half box, that 0 of our divisor. So positive 3 goes in here. You can ignore the curve here, the problem is just outlined, but this little kind of half box goes in the top left. The next thing we're going to look at is in our dividend, what was my highest degree, which in this case is x cubed. So we're going to put kind of above this bar placeholders from x cubed, you can see here, x squared, x to the first, all the way down to the constant, which is technically x to the 0. So whichever way you want to label this is up to you. Okay, and what we're going to write next to our number, but below our labels, are the coefficients. So the numbers in front of x cubed and x squared and x and our constant. So the 2, negative 11, 18, negative 9. Okay, so there's all of our numbers from our coefficients. Okay, next thing we're going to do is skip one line of space. We're going to write some numbers here. And we put this little bar that we're going to go ahead and like add with. Okay, so I'll just complete the whole outline there. So we write this little bar, leaving ourselves a little bit of room to write some stuff down on. And then we're going to drop down the very first coefficient. So 2 just drops straight down below this line. And the two rules we're going to follow from here on out are anything that comes below the line gets multiplied by our 3 in the box. Okay, so this 2 that dropped down times the 3 in the box. 2 times 3, 6. We write it below the next coefficient. Okay, then we're going to add. So our two numbers here, we're going to add negative 5. Below the line, multiply it by 3, negative 15. And then we're going to add positive 3. Times the 3 in the box over there, gives us 9. And we add, we get 0. Okay, so we actually just did our division. We just need to decode our answer. And so this is basically what we just got. This last calculation is always the remainder. The one next to it is our constant. So you could say x to the 0 or the constant. This is x to the first, and this would be the coefficient of x squared. And hopefully this makes sense. If we're dividing something that's x cubed by something that's x to the first, right? Fundamentally, our answer should be something that's x squared. And that makes sense that that's what we're getting for our answer here. So if we were to write out our quotient, it is 2x squareds minus 5x plus 3. And with no remainder, we don't need to write that extra fraction like we sometimes would, that plus remainder over divisor. So this is it. There's our quotient. Okay, let's take a look at one more example here. So if we were setting this up, first of all, can we use synthetic division with this? And the answer is yes. But remember, we need to find its 0, and that's what goes in that top left box. So in this case, positive 1. Okay, so positive 1 goes in this little top left box. I need my labels from my highest power up here, x cubed, x squared, x to the first, down to my constant. And we're going to write in our coefficients, 1, negative 4, 2, and 7. Okay, leaving a little bit of room So we're going to write a line of numbers here and our plus sign. So again, we get this started by dropping down our 1. And anything that comes below the bar, we're going to multiply by 1. So that makes it easy this time. 1 times 1 is 1. When I add, we get -3. Times the 1 in the box is -3. When I add, I get -1. -1 times the 1 in the box is -1. And when I add, we get 6. So remember that this last calculation is our remainder. This next to it is x to the 0, or the constant. We got x to the first and x squared. So our answer, our quotient, is x squared minus 3x minus 1. And remember, we wrote this like quotient plus remainder over divisor, that little fraction. So plus our remainder, which is 6, over our divisor. And this is the exact answer we would get if we did long division and wrote our answer with that form, right? Like we talked about mixed numbers. Okay, so that's how we do synthetic division. I'll also post some extra examples on Canvas and a picture of these, like the steps written out in words, if you'd like to see those. Okay, but this algorithm, this kind of process we just did, synthetic division, can also be used for something called synthetic substitution. So to give you an idea, let's say I gave you a function here, f of x, this quartic polynomial, and I wanted you to find f of -3, like plug -3 in and crunch all these numbers. Okay, there's two ways we can do that. One way we already know, which is called direct substitution. You would just directly plug in -3 everywhere at the right. Then we would, do our exponents first, -3 to the 4th, -3 cubed, -3 squared. Then we'd come back and multiply, and then we'd add and subtract, right, from left to right. And we end up with 251 is our final answer here. Okay. A different way, especially if we're doing it by hand that's very quick, is called synthetic. And it uses that same kind of setup process we just did. But if we want to plug in -3, okay, when we use this for substitution, not division, but substitution, you don't change that number. That number is what's going to go in that kind of top left box. Okay, so our setup is going to look something like this. The number we want to plug in, which is just -3, we don't change it this time, like the 0 of the divisor, we don't do that. And then these are my coefficients. X to the 4th, x to the 3rd, x squared. Notice this time though, if you are missing a power as we descend by, x to the 4th down to the constant, if you're missing any of those powers between, you have to put in a 0 as a placeholder. There was no x to the 1sts. We have to say there are 0 of them. And that is important when you do this process for division or substitution. Okay, so make sure if you're missing a term, including the constant, you have to put a placeholder. All right, so we've got all our coefficients. We drop this down. Remember, anything below here times the number in the box. So 2 times -3 is -6. When I add, we get -9. -9 times -3 is +27. When I add, we get 29. 29 times -3, it's getting a little tougher. That's -87. Plus 0 is -87. That times -3 is going to be positive 261, I believe. 261. And when I add, we end up with 251. And what do you know? Where we normally see our remainder, right? If we were doing this algorithm for division, is actually the output of our function. It's like the y value. If I plug -3 into this thing, we get back 251, right? Or f of -3 equals 251. So we can do this method to quickly plug numbers into large power polynomials. I mean, look at how many less calculations I had to do here. And yeah, the numbers for this problem were a little ugly at the end, but compared to doing all of these steps individually, it's much faster. So kind of cool. We've got two different things that we can use synthetic for. You can feel free to watch this back. Again, I'll have a picture of some previous year's boards on Canvas, and of course, that's where your assignment is. All right, thank you guys, and good luck.